Yeah, did that have a question? Yes, I have a question. They have a question.
Actually, it's like
Hello. Yes, the microphone works. Okay. Well, good evening, everybody. Welcome to Plus Ultra 2 and welcome to this Surviving on Mars event. It's our second event organized by First and Challenges in collaboration with Project Based, where we explore the future of space exploration through the lens of the Wageningen University and Research Credo for the quality of life. So what we are interested in this series is not if or how are we going to get to Mars and Moon, but how can we survive there as a species. In the first event, we had Vigor Barmelik, who was explaining about growing food on Mars and Moon. And tonight, we are going to take a broader perspective and talk about all kinds of technologies that are needed to survive on Mars and Moon, and also how far are we in developing those technologies, and also what the process looks like. So we are joined here by our expert, Charlotte Pouwels, and she lives the very adventurous and very wild life of an analog astronaut and researcher for ESA. She's also an ambassador for women in STEM, and she is a founder of her own company. So we are very glad to have you here. Before I give floor to Charlotte, I just wanted to share one practical thing. So after her presentation, there will be time for questions. So take your notebooks, write your questions. Also, audiences online, please engage. And without further ado, I would like to invite you to the stage, Charlotte.
Okay, first of all, amazing location. And normally I teach at Pouwels with Vigor, so I've never been in this building before, and it's pretty innovative already. So just a quick question. Who here actually studies at work? Raise your hands. Okay, those are many. And who here is actually really interested in space? Raise your hands. Okay, we have a good candidate. And last but not least, who would want to go to space? Well, still quite some hands. Okay, then I think I'm just going to add one more question to it. Who wants to go to Mars and actually live there? A lot less hands, yeah, what I figured. Okay, so hi everyone, my name is Charlotte Pouwels. I'm a space and launch engineer. I studied physics and space engineering. I normally work for the European government and on different other projects, mainly on making sure that we have navigation. So if you use Google Maps today, I did my work well. And basically, furthermore, I also have my own company conducting analog astronaut missions all over the world, which I will also talk a little bit more about today. But more and foremost, we're going to talk about Mars, and especially how we can survive on Mars and all the different factors that are needed. And it's not an easy piece of cake. You really need to have a lot of determination, a lot of science, a lot of hard work, and especially as well the entrepreneurial business mindset, because it will cost a lot of money to actually get there and get things sorted. So we're going to talk a little bit more about the Mars environment, just a basic understanding. I'm not going to bore you with all the physics, and I know you guys can also Google very well, so you will be able to figure that out yourself when you do the literature study. Why do we want to go to Mars? Why should we go to Mars? Is Earth not enough? This is more an ethical questions that get raised quite often by the public and by society. We're going to talk about the journey to Mars. So within the next decade, how are the upcoming plans from ESA, from NASA, JAXA, the Japanese Space Agency, looking like? We're going to talk about how to live on Mars, analog astronaut missions. What are analog astronaut missions? What can you do? And can you yourself become an analog astronaut as well? And last but not least, how can we implement all the research, all the science, all the engineering, and everything that we do for this back to Earth? And this is also a very interesting point for the challenge that's being done next year. So first of all, Mars, the fourth red planet. And most of you know that Mars is just this red dot in our solar system, but it's a pretty special planet because next to Earth, it could almost harbor life, or maybe millions of years ago, there was actual life. And currently we're researching different factors about Mars to see if this was actually the case. Was there water? Is there water? And do more research on this. But Mars is a very difficult planet, especially if you want to live on it. The radiation levels are about 50 times higher than here on Earth, which means that the concerns for cancer, concerns for modifications in the DNA are pretty insane, and we have to account for this. A normal spacesuit, this that I brought here today is just a demo, but a normal spacesuit only protects you with a layer of 1/8 of the dose. So that means that you still receive a lot of the radiation to your body. And all the damages, the galactic cosmic rays, radiation, all the damages that can occur in your body is a whole different topic. Then furthermore, the temperature. It's unfortunately not as comfortable as here what we experience in the Netherlands, but I think it's about 15 degrees right now. If you go towards the poles, it's about minus 125. If you go towards the equator, depending on where you go, of course, it's about 20 degrees. So again, how do you protect yourself against these temperature fluctuations? But also your materials. How do you protect your habitat? How do you protect your products? How do you protect your rovers against all these fluctuations? And furthermore, some other interesting facts is it has the largest volcano, of course, in our solar system. It has an orbital period of 687 days. But one Mars day is just a little bit more about one Earth day. So the cycle is pretty steady. Unfortunately, there are lots of dust storms, so large windstorms and desert storms, also how we call it, that you have to protect against. And last but not least, it doesn't really have an atmosphere, meaning you cannot breathe there. And the thin layer of atmosphere that is there is also not the most ideal to protect you against the radiation. Meaning that everything that's coming from the sun or coming from the universe is actually going to hit you. Ever wanted to protect yourselves against asteroids, micrometeorites, anything, you're not shielded from this. And on a later note, we're also conducting research to see if we can actually live subsurface. And the moon and both Mars have lava tubes. They have caves and lava tubes. So that could be a potential interest to see if we can live there. So why do we go there? Of course, everybody knows exploration is very fun, it's very imaginary. We all want to explore, at least I hope everybody here wants to explore and go out there if you want to go to space. But still, that is not enough. One of the main reasons why we do space research and why we invest so much in space is because the technologies that we develop for space is what we use back here on Earth. The cameras that you use on your mobile cell phone, mattresses that you've been comfortable laying on every night, different communication systems, navigation, as I mentioned before, all very important parts. Could you imagine living without your phone these days? Without internet, without being able to join this session via a video live stream? It's almost unthinkable. Furthermore, that's of course a science. One of the most biggest ethical questions that we get is we have Earth. We call it Planet A. Why would we go to Mars and invest so much time in it when we need to allocate those resources to be here back on Earth? Well, first and foremost, from my point of view, there is only one Planet A, and that is Earth. And we should do everything in our power to preserve that. But to further thrive as a human civilization and to become a multiplanetary species, to drive forward in innovation, we need to keep exploring. And for that, we can go to the moon, but even better would be to go to Mars, because Mars would be way more accommodating to the human body, as it has only 1/3 of Earth's gravity, instead of the 1/6 that we experience on the moon. So how do we get there and how are we going to do this? Who here has heard of Gateway? Raise your hand if you've heard of Gateway. Ooh, oh, tough one. Okay, who here has heard of the International Space Station? Raise your hand. Okay, it's a bit better. Who here has heard of all the commercial space stations that are currently being built? Again, not that many. So right now what the plan is in 2030, well, we think it will be delayed by a bit. The International Space Station will be not used anymore, and ESA, NASA, and all the other space agencies from other countries are focusing on the moon. And that one, the space station is going to orbit the moon, is called Gateway. And with that focus on the moon, means that there's more opportunity for business and commercial parties in the private industry to actually build their own space station. So while the commercial party is focusing on space stations around Earth, all the space agencies will focus on the moon and even further to go to Mars. Why do we go to the moon first? One of the major players to actually go to Mars is to have already the industry and everything set up. If we go to the moon and identify all the new technologies that we need, we know exactly what we can do to build and further and go beyond to Mars. Going to Mars will take 6 months to 2 years, depending on the orbit and when you actually go. If you go first to the moon and launch from there to Mars, it might even shorten. You would need less fuel, you would need less food, you would need less time. So it may be more efficient even. And then again, the Gateway missions are also called Artemis, and that is the next missions of us, humanity, going back to the moon. So next year, in October 2025, we're going to get the first astronauts back on the moon since the Apollo missions, which is a huge undertaking. I'm very, very excited to this because there are some new documentaries that are coming out as well that we've worked on, and this is just a huge milestone for space, but also for humanity. Who here has watched on Friday the spacewalk from SpaceX? Ooh, okay, guys, if you get home tonight or if you have a moment, go back to YouTube and find the spacewalk that was done by SpaceX. This was the first commercial spacewalk that was done by non-astronauts. We also call them commercial astronauts. Basically, people who are not that trained, have not gone a rigorous selection process of ESA or NASA or any of the other space agencies, but have been able, with minimum amount of training, to conduct their own spacewalk. Very, very impressive. Next, go back to Mars. How do we live there? So if you look at your left and you look at your right, look at the neighbors who are sitting next to you. I'm not sure if you already know each other, maybe you just met tonight. Now imagine you will be living together for 2 years in about 60 square meters. I'm not sure who can remember the COVID period that clearly, but living together with absolute strangers that you really haven't met before or you really don't know them on such a personal, deep level is quite challenging. Now imagine you have food for these 2 years and everybody gets a ration. You get a certain amount of this, you get a certain amount of potatoes, you get a certain amount of salad, and some chocolate powder even to make hot chocolate milk. Now, the crew member on your left takes more chocolate milk and actually steals it. How would you react to that? And if you react to that, and this is very possible, this happened on my analog astronaut mission actually. I was very upset because some people took my hot chocolate milk. And when you try to stay stable, mentally stably, physically stably, you really need to make sure that you thrive, and food is such an important player. So that's the human part. Trying to stay mentally stable, working with your environment, having enough nutrition, and while still staying protected against the harsh environment on Mars. So how would it look like if you would colonize Mars? Well, this is the most ideal situation. You have your full lab, maybe even a Wageningen university building located on Mars. You would have rovers or trucks that could actually drive there. You would have roads. You would be able to make roads because the regolith, that is how we call the sand, the top layer of Mars, is very harsh to work with and actually not ideal, as well as poisonous, and it has some sharp metals as well. Dust storms, again, how do you protect yourself against that? So as mentioned before, there are lots of food factors that we have to take into consideration. We have the psychological factors, stress, isolation, crew dynamics, the environmental, the radiation, gravity. If you would try to grow a plant here on Earth, it would go upright, right? The roots would go downwards and it would suck out the water, it would suck out the nutrients and go upwards. If you go to space, for example, here in low Earth orbit, you would have a reduced amount of gravity. We call this microgravity. So the plant has trouble with finding its orientation because it no longer gets the roots towards the center of gravity, but it can go anywhere. So the plant is confused. So how do you account for that and make sure that your plant actually grows well, is thriving, and is producing the food that you need? If you grow foods and it's being exposed to radiation, how do you prevent it's not causing any malformations? For example, the tomato can absorb some of the radiation and actually can cause damage. And suddenly that tomato that you like so much is no longer edible. You can no longer eat it. Or when you eat that tomato, will it cause any effects to your body? Will it cause you to become sick? Will it cause for you to get cancer, for example? Those are also things and lots of questions that we still have. And of course, the ethics. When we might like a tomato, somebody from another country might want to have a cucumber, or they might want to have noodles, while somebody else wants to have a wrap. So who decides who can bring what food and what food will be produced? When there is a holiday in Mars, for example, you want to celebrate Christmas. How do you celebrate Christmas? What are you going to eat during Christmas? Who decides what meal is being cooked? Again, cultural preferences really come into play. And then furthermore, are there other methods to actually produce food? So one of the most innovative technologies that's currently on the ISS is for Made in Space, is a 3D printer that can 3D print a pizza in space. Now you might think, why do we want pizza in space? What would be the whole deal of it? I can just eat a wrap, I can eat anything else. Well, if you can manufacture and produce your own food, your own meals, and more complicated meals yourself, you're able actually to share a meal in such a way. You don't have to keep eating dry freeze meals. Who here has gone on a hike to a mountain and used those dry freeze meal packages that you add hot water or you add some water to it and then you eat it? Okay, quite some. Good. Hiking is very important. If you eat that for one day, maybe a week, it's quite nice. Would you want to live on that for 2 years? No? Would you start missing a paprika or a tomato or fresh fruits, fresh vegetables? Yes. So if you're able actually to make more complicated meals, it would elevate the spirit of the crew, but it would also, your body would love that nutrition. Another way that we're looking into is vertical farming. Again, we have problems with the plants and with gravity orientation. So if people are thinking of business ideas, try to find a solution maybe to find vertical farming, but then introduce microgravity environments, or for example, on Mars environments, how would you find a solution to that? Water reacts differently when you have different gravity levels as well. So suddenly the plant will have a lot of difficulty to actually soak up the water. It will actually create more force. So the plant will need to exert more of its energy. And then how would that look like? So one of the ideas is to have your module, your habitat structure, and then having another structure connected to it. But what if one of the plants gets sick and causes for some disruption? Would you want that sickness or the fungus or anything like that being connected to your habitat module where your crew is living? Would you want the fungus to be spread through the ventilation systems when you're sleeping? You might get sick. You might need antibiotics. How do you get antibiotics on Mars? All things to take into consideration. You need to start thinking about this. The first problem, how do you get everything there? How do you produce? How do you eat? And how do you make sure that the cycle keeps going? And by the way, there are multiple simulation softwares, open source, to do these kind of simulations that are out there. Okay, and here you can see one of the astronauts, Jessica Meyer from NASA. She's actually enjoying some of the self-produced foods that they grow on the ISS. And this is a rare occasion because you might know, might seem logical, it will take 2 weeks to maybe 6 months to grow some of these vegetables. So when you finally, after all those dry freeze meals, finally can enjoy your salad, you're very, very happy. And now last part is the analog astronaut missions. So who here knows what an analog astronaut is? Just raise your hand. 10? Okay, so an analog astronaut is not an astronaut. One of the most, things to get confused by. An analog astronaut is basically a guinea pig here on Earth who's being subjected to tests that they want to bring to space. So basically an astronaut has to go for 2 years. How are these people going to respond to each other? Are they going to kill each other? Are they going to fight? Are they going to do something disruptive? They want to identify that first before actually sending the people there. Other factors are human-robotic interaction, or if you want to test a new research before it actually goes up there and make sure that you have figured out all the bugs, you test it during an analog astronaut mission. So again, analog astronauts are guinea pigs. We love being guinea pigs. We love being subjected to tests. You take your blood, you take your heart measurements, everything in your body gets measured and shared by researchers. So if you're comfortable with that, I definitely recommend to look into it. There are many missions all over the world. There's a Wikipedia page where you can find most of the missions. You can go to the website and you can actually see if you want to apply for one of them. Some of them you need to be a US citizen, some of them you need to be a European citizen, but most of them are open to all, which is a very big factor that we're pushing for. Because space is not for one culture or for one country, it's for everybody. So that is where my company comes in. In 2019, I talked to Wieger Wamelink, the professor who gave a lecture before me, and he basically sent me as part of my research that I was doing with Wieger to ICEE, which is the analog facility in Hawaii. Unfortunately, there was a volcanic eruption, so it is no longer active. But basically, we conducted research to see how people can actually grow food themselves, and especially in these harsh conditions. But why stay in Hawaii? Hawaii is a bit far. Can we not do just all over the world? And there are also different factors that we want to look into. Do you want to go subsurface? This, for example, is in a lava tube in Iceland, about 160 meters deep inside a lava tube. Do you want to go to a desert? Or do you just want to stay inside and just do psychological research or agricultural research? So my company basically provides analog missions all over the world. It gives you great opportunity to travel all over the world. Yesterday I was in Switzerland. Next week I'm flying to Greece. The week after that I will be in Italy. You basically get to travel all over, which is one of the most exciting parts of being an entrepreneur in this. And that means that we basically can do an analog mission wherever you want to do it. And might even be here at Wageningen University. We might be able to set something up here as part of the food challenge, or maybe see if the Netherlands can have its first own analog mission itself. So there are also more of these missions that are going to be published. You can follow our website as well, or our Instagram or LinkedIn, or go to Wikipedia page and basically sign yourself up if you want to learn more about it. Then there are two parts. You don't have to be an analog astronaut to join in these missions. You can also submit your product or your research. So if you have a great idea or you need some testing to be done and you want to bring your research further, you can submit your research work or your product to these missions. And sometimes you can go to the mission to actually execute the test yourself or be part of the crew. Or sometimes you just do it remote here from the Netherlands. And just to give an impression, it's not only science and engineering. There are also lots of artists who are thinking about how can I create music in space? How can I create art in space? And here I wanted to show you a short video of how Hawaii looked like. This was a 14-day mission in collaboration with ESA. It's called the EMMIHS-II mission. There were 6 missions in total. And we basically were locked up with 5, or in total 6, strangers for 2 weeks. And this was during the Christmas period. So we got to experience how to celebrate Christmas together with all these different cultures. how to survive for 2 weeks in this extreme location, and actually how to explore these lava tubes and see if they are feasible to live in if we want to go to the moon or Mars. And especially how do you design a habitat for that? And just to go back on that, if you want to design a habitat for Mars and for a lava tube, for example, you see a picture here on the right corner. That is one of the habitats, an inflatable module that you, for example, can deploy within 2 hours subsurface. Again, if you deploy something on Mars and you want to bring your food systems, everything that weighs more than 1 kilo is going to cost you. How are you going to get investment? How are you going to get parties to align to actually spend the money and the effort for that? And that's why we're looking towards inflatable technology as well. So if you're thinking about product designing or thinking about a challenge, think about how cost-effective, so low mass and capacity in terms of size as well, because it has to go on a rocket. Unfortunately, we cannot teleport there yet. I'm waiting for someone to figure that out. And then last but not least, again, how do we bring it back to Earth? I'm not sure who of you have heard of Wieger, his research, where he used urine samples we have someone here in the back, great, from festival people in Amsterdam to actually conduct his research to use struvite, which is a subtract of the urine, to grow plants faster on Martian and lunar regoliths. Very interesting work. And in that regard, ESA is also looking into, together with Melissa, it's an organization in Spain, to actually create this closed loop system. So we can look at cities, we can look at houses and create this closed loop system to make sure that the energy is reduced and that all the waste that you produce, your feces, your urine, the air that you breathe out, to bring it back in this cycle and keep making sure that you keep recycling everything that you have so you don't waste anything. And if we implement this technology because we need it for Mars, we can bring it back to every city. Can you imagine how many resources we can save? And how much more we can make sure that everybody has the right amount of resources? Just food for thought. Another point, another technology, especially in agricultural, is getting very important right now. When we look at the moon and we look at Mars, we create heat maps because we want to make sure that we go to the spot, for example, near the equator, where it is a comfortable 20 degrees Celsius, so that our materials and our humans can thrive there. But we can use the same technology, use the satellite data and the heat maps that we produce to, for example, inform farmers that there's a heat wave coming and that certain spots of their crops are going to be affected. Then they can countermeasure that by adding more water to those certain areas. And last but not least, I really want to thank you for your attention. I think we're right on time. And if there are any questions, I will be happy to answer them.
So I will open the floor for questions in a second, but first I wanted to ask you, can you tell a little bit about what is here?
Yes, so one of those suits, one of the demo suits that we work with, you can see it here. This is just the outer shell. Normally you can pressurize some of these suits don't have to be pressurized. The size of the bulb is basically because you add an augmented reality system in there, a HoloLens 2, so that astronauts can put up their procedures. Another important factor is that Mission Control Center here on Earth could see what the astronauts are seeing. For those who have actually watched the spacewalk of SpaceX, you could see the first heads-up display, EVA, live vision from the astronaut. So you saw the astronaut through the eyes of the astronaut going outside into space. Incredible innovation. And yeah, this can basically be used for simulation purposes.
Okay, great. So the floor is open for questions. Who would like to ask them? Yeah, can you shout, because we only have one microphone and we want to make sure that people online can hear. The most, which another mission is the most? Whoa.
Oh, there are so many good ones out there. My passion lies in extreme environment testing, and especially on spacesuits, because I did a lot of research on spacesuit design and implementing new technologies in spacesuits. So I would go for any of the analogs that is really outdoors. You have one that is located in the US. It's called MDRS, Mars Desert Research Station. They've been doing work for like 40 years. You have one that's in Devon Island, up like near Greenland. The one that I do is in Iceland, which is focusing on lava tube subsurface. Also a beautiful location. You had one that was underwater, was called Nemo. Unfortunately, that one also got destroyed by a storm. This is the whole problem. We are in extreme locations, so these ones either get destroyed by volcanic eruptions, storms, underwater storms. Yeah. Which one else? Well, I would say if you want to do an analog machine yourself and you want to start something and you have a research idea, I would go for Lunaris in Poland. That one was a former ESA collaborative analog habitat that's being developed. It's very accessible and a lot of students do their master thesis there. So it has a lot of opportunities for students too. Okay.
I'm curious about what are the experiments on agriculture in space? What are the latest or the most interesting?
So anything related to soil in space is very difficult. Again, what I mentioned about water. Water moves differently in space, so water-soil combinations, that's why they're mainly interested in hydroponics and vertical farming. Again, the gravity factor is very problematic. 3D printing in space. Cultural aspects, so which food has the most nutrients. Most people look at potatoes because they have the most calories per square meter. Unfortunately, potatoes take a lot of space, and some even are looking into combining different fruits or different vegetables and create this one new species, basically, this ultra food that combines multiple nutrients at the same time. Other people are looking into pills. Unfortunately, for cultural aspect, that is a little bit less exciting, but if you can have this one super pill that provides you with all the calories that you need, it will be more efficient, especially if you're out there or you need to be rescued and you just need to have the energy.
Yeah.
What is your background and kind of your career path and where you are now?
I started with applied physics, and I focused on radiation. That's when I got involved in ReThink. I did plasma thruster research for CubeSats in Australia. Then I went to France to do space engineering. Then I started to work at Airbus as a test engineer, so really focusing on destructive testing for space, so satellites, solar panels, basically anything that you need. Then I started to work for the Galileo program on the launches, so Ariane 6, and basically making sure that our satellites stay operational around Earth. I definitely recommend for somebody who wants to go into the space sector, if you have a science background, the most easiest path forward is really to go into a PhD, because that is something that they're mostly looking for if you want to do science. If you want to do engineering, then look at the companies who are out there, go into the private industry, and from there you can go to governmental. But if you want to do the hardcore work, then I would stay with the industry, because the government mostly have contractor companies such as Airbus who actually build the satellites. So if you want to work in a clean room, if you want to work in a lab, then definitely look into those.
Who would like to follow Charlotte's path?
So who here has an agricultural background? Most of you. Okay, perfect. So if you want to go into the agricultural sector and you want to combine it with space, I would definitely look into Melissa. Let's see. And look on the work that they are doing. It's this one. You have Samila and Melissa. They're really focused on closed-loop agricultural systems for space, and they really do a lot of work on that. Okay, and also how to relate that back to Earth. Yes? So, like a chicken or a cow or? Well, we looked into that, especially during analog missions, because we need some companionship. And if you have to take care of a pet, it is, we already tried it with plants. So using plants as pets. And it definitely has a lot of value on a psychological level. In terms of mass, it will be a freaking expensive chicken. 1 kilo can easily cost up to 10,000 euros just to get to suborbital orbit. And if you want to go to space to where the ISS is at 408 kilometers of altitude, 1 kilo would be 100 to 200,000 euros. I'm not sure how much the average chicken weighs, but yes?
Insect?
Yeah, insects are high in nutritional value, and I think there's a lot of research going on about that as well.
Already looking at that.
Yes, especially worms, I think he's looking into.
Mealworms.
Mealworms, yes. Yes, definitely. I don't know too much about it. It's Wieger, his expertise, but that could definitely help. I think they were also looking into certain insects that you could put into homeostasis. So you actually put them to sleep, and you reduce some of the moisture. And then when you're at Mars, you revive them. Basically, you add moisture and they come back alive. But this is something, again, I would not be sure about. You would need to check. Maybe go to Google Scholar, look at some of the papers that are doing research on that.
But it could be interesting with respect to circular farming. So you use side streams from plants to insects and then produce animal source proteins with a very high nutritive value. So
Yes. Yes.
from that view. Yeah.
Okay.
Yes.
From your own experience, do you think it's feasible to be underground for a long period of time on Mars or?
Yes, I definitely think so. We have done 4 missions now in Iceland in a lava tube. People were locked up between 3 days to a week. Next year they will go for 2 weeks of service. And I am kind of an extrovert, but I also prefer to be by myself. And when you're in this closed environment and you have no social media, no telephone, no people who are constantly bothering you, you really find this kind of mindfulness, zen. So for me, that is a holiday. So, but again, it depends on your personality and how you interact there. Some people feel claustrophobic. For them, I would not recommend doing that. Yes? Yes, the one of foremost problem is entering. You have to enter these lava tubes via holes in the ground, which are called skylights. And unfortunately, with satellite data, we cannot penetrate too deep into the skylights. So it can just be a drop down of 100 meters, or it can be a slope where you can gradually move in. So we would actually have to go to the moon and we have to go to Mars to explore how it looks there. Then you have to bring everything in. So when you go back here, you see the habitat on the right small picture. That habitat in total weighs around 200 kilos. It's being packed in containers of 30 kilos that can be carried by 2 people inside the lava tube. And this is one of these skylights that you can see. You can gradually go in there. If you have to carry 200 kilos there with your rovers or by the astronauts themselves, even with the reduced amount of gravity, so there would be less mass that you would feel to carry, it is still pretty difficult. The other part is the rocks. They're quite sharp, so they can damage your materials, and rocks that can fall down from the surface that could damage your structure or could even kill possibly an astronaut if it falls on your head. I hope that answers the question.
Yeah, there's a question.
Yes?
There's also some research about algae, like like food.
Yes.
Space, I don't know, for the less consume of oxygen or something like this.
Yeah, so I'm not too sure about algae, but they are looking into it, especially as well for an oxygen supply, because there are certain algae that produce, and of course, the oxygen, so you can use it back into your environmental closed loop system. And you can eat them, I think, as well, like certain algae. So yeah, definitely look into that. Yes? Very, very good question. Most of the astronauts that are being selected, they have to be in very fit condition. I have not seen that as a criteria for the selection yet. What I do know is that in total, the mass budget needs to be a certain level for the launcher to reach a certain altitude. I think that they rather have it that you're like a little bit on the lower side so that they can add more experiments to it. Although I do know that for some of the astronauts, they actually have to gain weight. And especially if you have a lot of muscle mass deteriorates quite quickly in space. So athletes are not that fun to go to space because they lose most of the muscle mass and you lose your strength. So for astronauts, they normally look just at average people who are in good condition. You don't have to be a bodybuilder. You don't have to be able to run 200 kilometers. Just a normal sized person who has a good health.
We have some questions online.
Yeah.
Yes.
It's a question from Rob. Is ICEE Space collaborating with BASE? And what challenges do your companies face that we could help to solve?
Oh, that's a good one. I don't know who Rob is, but yeah, feel free to contact me after this. Yeah, so BASE, I work normally with WIEGER, so we're looking into seeing how we can potentially collaborate further, especially in regards to the food challenge as well, and maybe setting up a habitat here in the Netherlands, because I've been pushing for like 4 or 5 years already to get a habitat here to do more testing. And in terms of business challenges, I normally do my work and my research all outside of the Netherlands. And that's mainly because the Dutch industry isn't very fond of space exploration. They're mainly looking towards satellite navigation, satellite security, satellite communication, and Earth observation. So if Rob is able to make sure that we can have more space exploration here in the Netherlands, perfect.
Another one, is there a corpus of thesis work that you would like more attention from students?
Oh, yes. So actually my last master thesis student just finished from the TU Delft. So we have a few new openings. I'm more focused on spacesuits and space habitats. So it would go for master thesis students to go towards habitats and suits. But there are always openings to see if we can combine maybe with WIEGER or maybe with someone else, another professor, to look into the agricultural aspects.
One last, during your missions, did anyone barter or trade for supplies?
Yes, they always do.
Thank you. It's all from all. Okay.
Any more questions from the audience? There's one more there.
Because if they do find little organisms living in the Mars soil, deep in soil, I can imagine there's bacteria.
Yeah, one of the things for lava tubes is to go there to see if there's actually life or bacteria that survives when Mars lost its atmosphere. At least that's what we think that happened. First of all, the researcher who would find that would probably win a Nobel Prize. A very good one. Then you would need to do more experiments and actually try to preserve the life. Try not to get sick, especially if there are these different kind of bacteria that can damage our human body system or like our human system. If you bring that back to your crew, you can basically, there is a potential hazard of killing your whole crew, and you don't want to deal with that. Yes, there are actually already bacteria from our end on rovers that are out there on Mars. So we have actually already produced bacterial life probably there. If it survived, we don't know. We don't know if it survived. But when you touch something with your fingers, you of course try to wear gloves. You already do that. But polluting Mars and damaging possibly another life system there, that are both of the ethical questions that we really need to think about. Because right now, space is for everybody. There are certain laws, certain treaties, but the parties or the countries who connect to it, they don't really have to oblige to it. They try to oblige to it, but it only accounts to their governments. So if SpaceX, for example, would go to Mars, they don't have to follow the laws of that treaty, which is very detrimental. So if you have a research station on Mars and who finds life, and you have an oil company who wants to dig for certain materials there, which can damage the life up there, yeah, that can cause friction. And there really needs to be a big push on law and government to make sure that we unite in this. So if there are any lawyers here and you want to become a space lawyer, we need you.
Okay.
Sorry, could you repeat the question? Good one. Yes. So right now, most of the female astronauts, they choose to not have their period in space just because tampons take mass and it's just a lot of hassle. The bathroom there is not really comfortable. It's like a vacuum system. It's not really ideal to cope with that, but it would be something that we need to look into. Another part is babies in space or reproduction in space. Also big questions, big topics that we still haven't found a framework for. There are some researches being done on menstrual cups to use those in space, but again, it is very the beginning stage, so lots of new work needs to be done on that.
I think there was one more question, right? Let's say it's the final one.
Okay. About the substrate of the plant, the earth, or that you use to grow your plant. Because when you finish the quality or the nutrient in your substrate, you have to substitute with another. You have to change with another substrate. So the point is, there is some research to make in a quick, not real earth, but that is equal like the earth in earth. And I know you have some specific microorganisms and mineral that you use to recreate like terraformation, like something like this. Because in this way you have the problem of the substrate. When you finish your substrate, you can make another one with only a key and not contain real earth.
Yeah, so Vickers research is mainly focusing on using the soil that's already present there, and we call this regolith. So the Martian regolith to see if we can grow crops in there. We need to add things to that for sure, such as the strophites, but lots of other elements need to be added to make sure it works. One big factor, the first few meters of the soil on Mars you cannot use. There are secondary radiation particles, it's very sharp, very fine, and it can damage your plants. So we're not really looking into bringing compost or the substrates from Earth, really, but more looking into the in situ resource utilization, so local resources.
Real terraformation.
Yes. Yes. Yeah. Basically using what you have there at hand. I think that was the last question, but I will be here for the
If there is one last question, that's okay.
There's one last question from Devrin. If you had to pick one constructive suggestion to pursue this field, what would you suggest for the audience in front of you?
Good question. Can you repeat the question again? Like constructive view, just in terms of career perspectives, or?
Yeah, I think to pursue this field, I think.
To pursue. Stay true to yourself. Academics can be very hard, and really try to stay aligned with yourself, what you want, and don't get crazy about all the information and everything that's out there. Like, really keep checking in with yourself, stay as close balanced as you can, and keep driving for innovation, keep pushing forward. Because the moment you give up, the moment you don't keep pursuing, we lose a lot of talent to solve these world problems that we have.
Okay.
Thank you very much for your inspirational talk. Charlotte will be here during the drinks and bites, so I would like you to invite to talk to her. And I would like to close, if I could use this one, with a short teaser, because as you know, this event is part of the ReThink Food Challenge. So I would like to invite you. I think I went the wrong direction. I would like to invite you to consider joining the ReThink Food Challenge. You can ask me any questions about it, but I will do this teaser. Here you can find more information about the challenge, and we have also a couple of events coming up. Check the QR code. I know that there's a couple of people here who have green stickers. Those are people looking for the teams, so also make sure that you use the time with drinks to connect and meet each other. And Charlotte, thank you very much. It was a great pleasure to have you here. The floor is yours to drinks. Yeah. Was dat die met de is? Oh, hij is weggelopen. Oh, bij moment, ja. Oh, ik wist niet dat. And we can stop the webinar. Yeah. And we can keep the slide for people. Yejin. Hi, Yejin. Hello. Hi, it was very, very nice. We're leaving now? Oh, no, we're waiting there. Yeah, it's okay, yeah.